Well, first of all, I was very glad to be able to accept the invitation to speak at this conference. I had visited Lisbon a couple of times before, enjoyed it a great deal, both academically and on the cultural side, and so was very happy to come back given my previous experience. I also was honored to be able to give a talk in memory of Jean-François Mertens, who was a game theorist that I enormously admired and also liked a great deal personally. He was a friend of mine. So for all those reasons and for the great audience that I would have here at the conference, I was glad to accept. I decided to speak on some recent work I've done with Partha Dasgupta on voting methods. This is motivated by the fact that the voting methods that most countries are using these days for electing presidents, for example, have some serious flaws. And you have only to look at how Donald Trump became president in the US to see what the consequences of those flaws might be. Our approach, which actually follows in the voting theory tradition, is to first step back and consider what do we really want out of a voting system? What properties would a good voting system satisfy? And we identified 6 properties, actually, that we thought were especially important. These properties are not original to us. They've been around in the literature for years. One is the Pareto, it's called the Pareto Property. It means that if everyone thinks that candidate X is better than candidate Y, Y shouldn't be elected. Another is anonymity, which says that all voters should be treated equally. A third is neutrality, which says that all candidates should be treated equally. A fourth property is called independence, or independence of irrelevant alternatives, which says that if we run an election and candidate X wins, but then for some reason we decide to run the election again where some of X's competitors are no longer running, so we run the same election over with fewer candidates than before, well then X should still win. The irrelevant candidates who have dropped out should not, the fact that they've dropped out should not change the outcome. The fifth property is what's called decisiveness, which just means that there should be a clear-cut outcome of the election. There should be a winner. And then finally, voters should not have the incentive to vote strategically. They should vote what they really think. They should not be voting in reaction to other voters. Well, it turns out that you cannot satisfy all those properties all the time. This has been known for many years, first from the Arrow impossibility theorem and then the Gibbard-Satterthwaite impossibility theorem. So what we did was to say, well, granted that you can't satisfy them all the time, which voting rules will satisfy them as often as possible. If you want to satisfy all 6 properties, majority rule is the only voting rule which satisfies all 6 properties as often as possible. Now, what is majority rule? This was proposed by the Marquis de Condorcet in the 18th century. What he said we should do is to allow voters to rank the candidates. So you might say, well, I like X the best, but if X doesn't win, then I want Y. If Y doesn't win, I want Z, and so on. And then the winner is the candidate who, according to the rankings, would beat each of the other candidates by a majority. So majority rule is the voting rule which satisfies all 6 properties, not all the time, but more often than any other. Now, of the properties that I mentioned, the 6 conditions, probably independence of irrelevant alternatives is the one that is the most controversial. This is the property which says that if we drop some of the candidates from the ballot, we should still have the same winner. This has sometimes been attacked as an inappropriate demand. So we wanted to explore what would happen if we dropped it, and then it turns out that there are 2 and exactly 2 voting rules which satisfy the properties as often as possible. One is majority rule, which I already described, and the other is what's called the board account or rank order voting, where again voters rank the candidates, but now every time a candidate is ranked first, she gets n points, assuming that there are n candidates. She gets n minus 1 points if she's ranked second, and so on, and then we just add up a candidate's points over the voters, and whoever gets the most points wins. This was proposed by Jean-Charles Borda, who was a contemporary of Condorcet in 18th century France, and in fact Condorcet's arch rival, intellectually speaking. And rank order voting and majority voting are the 2 most intensely studied voting rules in the 200 years or the 250 years since Condorcet and Borda were around. We think that it's satisfying that, in a sense, our paper resolves some of the tension between Condorcet and Borda, because we're showing that, in a sense, Condorcet and Borda were both right.